Hi, Algebra 2. This is Mrs. Cowles, and today I'm just going to go over a few of the questions on the review from solving quadratic equations. In this video, I'm going to focus on solving quadratics that do not have the linear term. So it's only going to be made up of a quadratic term and a constant. An example of that would be question number 5. If we take a look at question number 5, it's x squared minus 49 equals 0. Now, this, if we take a look, is the difference of two perfect squares. So we have two ways in which we can factor this. One of the ways, or not just factor it, but solve this. One of the ways is to go through and factor it. If we recognize it's a difference of two perfect squares, we know that that's going to factor into a plus b, a minus b, where a and b are the square roots of a squared and b squared. So we take a look, x squared and 49, we take the square root and we get x and 7. So this is going to factor into x plus 7, x minus 7. I set each factor equal to 0, and using the zero product property, we know that the first one will give us x is equal to negative 7, and the second one will be x equals 7. Another way that we can go through and solve this is just by solving for x squared, getting the x squared term alone and removing the constant. So we start by adding 49 to both sides. Once we have it added, we can go ahead and solve for x squared by taking the square root. And when we solve taking the square root, we have to include both the positive and negative square root of 49. So my solutions are x equals plus and minus 7. You can see that no matter which way we do this, we will come up with the same set of solutions. Other problems that fall into this category are questions 11, 13, and 15. So again, x squared minus 1 equals 0 is the difference of squares. So I can use that pattern where I take the square root of x squared and 1, and that becomes x and 1. That factors into x plus 1, x minus 1 equals 0. The zero product property says in order to multiply to 0, one of our factors must be equal to 0. So I set x plus 1 equal to 0 and solve it, and we get x equals negative 1. And when I set x minus 1 equal to 0 and solve it, I get x equals positive 1. Again, you could just go through and solve for x squared by adding 1 to both sides, taking the square root, and remember when solving, you have to take both the positive and negative square root, so we end up with plus and minus 1. So let's take a look at question 13. Now, in order to solve this by factoring, we would have to go through and set it equal to 0. But since I see that I have the quadratic and I already have the constant term on the right side, the best way for me to solve this would just to continue to get the x squared term alone. So to do that, we're going to divide both sides by 2. So I have x squared is equal to 121. Now to solve for x squared, we're going to take the square root and we get x is equal to plus and minus the square root of 121. And the square root of 121 is 11, so x is equal to plus and minus 11. I think that's the easiest and fastest method for going through to solve that. If the constant term is already on the other side of the quadratic, just continue to solve. Same thing with question 14. To get x squared alone, you would divide both sides by 3, x squared equals 4, and then to solve, you take the square root. X is equal to plus and minus 2. Now we're also going to take a look here at question number 15. Question number 15, some of you are going to look at and recognize right away that we have the difference of two squares. So we can go ahead and take the square root of each one, and we would have 5x, and we would have 3. So if we were to factor this, we would have 5x plus 3 and 5x minus 3, and we would set that equal to 0. Now you're going to take each factor and set it equal to 0. And when you would solve that, you would subtract 3 from both sides for the first one. 5x is equal to negative 3, then divide both sides by 5, and x is equal to negative 3 over 5. As you would continue to solve the other factor, 5x minus 3 equal to 0, it's going to be a very similar answer, except because you are adding a positive 3, your answer is going to be positive 3/5. So you continue to show the steps, x is equal to 3 over 5. Now you could also take that same problem, and I will do it above, where you can go through and actually solve it using the square root method. So I'm going to go up here and I'm going to rewrite that. 25x squared minus 9 equals 0. You could go through and add 9 to both sides. 25x squared equals 9. Divide by 25. Now just if you take a look and you see you got perfect squares, don't use your calculator and divide it out. just leave it as x squared equals 9 over 25. And then when you take the square root of a fraction, take the square root of the numerator and the denominator. X is equal to plus and minus. The square root of 9 is 3. Square root of 25 is 5. So again, don't rely too much on your calculator. If you see things are perfect squares, leave it as is and continue just to take the square root of those. So hopefully this was helpful as you continue to try to solve quadratic equations that only have the quadratic term and the constant term.